Welcome to our deep dive, everybody. Today we're going to be looking at data and statistics, and hopefully you will leave this deep dive feeling like you can kind of understand this world a little bit better.
Yeah. Data is everywhere.
Right. It is.
You can't escape it, and yet...
It can be confusing.
Oh, it is, absolutely.
Yeah. So we have a chapter here from Study Guide, focusing on collecting data, and then I have this note that just says, association does not imply causation, which we will get to.
Very important. You hear that all the time.
Right.
And it's easy to sort of miss it.
Yeah, to fall into that trap.
Exactly.
So by the end of this deep dive, you should be able to spot bias in studies, think critically about data and how it's presented, and understand experiments and how researchers use them to establish cause and effect relationships.
That's right. And that's important because... Well, because these are the building blocks for understanding so much of the information that's thrown at us every day.
Yeah, like the news.
The news, absolutely. Or, you know, health studies, trying to decide... what kind of food to eat.
That's right.
All of that is based on data.
So let's unpack all of this and get started, I guess, with like the actual structure of data. How is data structured? I imagine like a giant spreadsheet.
Yeah, like a giant spreadsheet.
Yeah.
That's not a bad way to think about it at all.
Okay.
So basically, in a spreadsheet, you have the rows and the columns, and the rows are called cases.
Okay.
Each row is a case. And a case could be a person, it could be a city, it could be a product, whatever the study is focusing on.
Right.
And then the columns, those are called variables. And those are the things that are being measured about each case.
So if we're looking at data on like dog breeds, each row would be a different breed of dog?
Each row would be a different breed of dog, exactly.
Okay. And then the columns would be things like their height, average weight, average lifespan.
Oh, absolutely. Yeah, you got it.
Okay.
So those variables can be categorical, meaning they put things into categories, like breed group or coat color. Okay.
Or they can be quantitative, dealing with numerical measurements.
Got it. Categorical is for grouping. Quantitative is for measuring.
Got it.
Now, the study guide mentions something about explanatory and response variables. What are those?
Right. So explanatory and response variables, those are key to figuring out if there's like a relationship going on in the data.
Okay.
So the explanatory variable is like the thing that we think might be influencing or predicting the response variable.
Okay.
So for example, if we were studying how exercise affects heart health,
okay,
the amount of exercise that people get, that would be the explanatory variable.
Okay.
And then measures of heart health, like blood pressure or resting heart rate, those would be the response variables.
So we're trying to see if there's a relationship there.
Exactly.
Does more exercise lead to better heart health?
Exactly.
Now, speaking of relationships, we need to talk about sampling and bias, making sure the data we're looking at is actually representative of the bigger picture.
Yes, absolutely. So the study guide emphasizes the importance of random sampling.
To avoid bias.
Right, because if you only polled people at a gym to understand national exercise habits, that would be a very skewed picture.
Exactly. You'd get a very skewed picture. Your sample needs to actually reflect the population that you're trying to study.
Right.
But even with random sampling, biases can kind of sneak in.
Oh, really?
Yeah. Like what?
So think about volunteer bias.
Okay.
So the people who choose to participate in a study, they might be different from those who don't.
Oh, that's a good point.
Yeah.
It's like those online polls that you see, like 90% of people love pineapple on pizza.
Right.
Like, no, they don't.
Exactly. Probably only the people who feel very strongly one way or the other are even bothering to click on that poll.
Right.
And then there's social desirability bias, where people give answers that they think will make them look good, even if they're not being entirely truthful.
Oh, yeah.
So imagine a survey asking, how often do you exercise? Some people might bump up those numbers a little bit.
Oh, totally. Yeah, I would for sure.
Yeah. Exactly.
So understanding potential biases is super important for just interpreting data responsibly.
Absolutely.
So now let's get to this note that I have that just says dramatically, association does not imply causation.
Right. And this is so important because it's so easy to think that if two things are associated, that one must cause the other.
Yeah.
But that's not necessarily true.
Right.
Two things can be correlated, meaning they tend to happen together without one causing the other.
Like ice cream sales and crime rates both go up in the summer.
Classic example.
Right. But that doesn't mean that eating ice cream turns people into criminals.
Exactly.
There's probably a hidden factor at play, like hot weather.
Yeah, exactly. A confounding variable.
A confounding variable. Okay, so how do we go beyond correlation and actually prove cause and effect.
That's where experiments come in.
Okay.
They're really the gold standard for establishing causation.
I'm intrigued. What makes a good experiment so special? So in a randomized experiment, you have participants, and they are randomly assigned to different groups.
Right.
And the reason for that random assignment is to ensure that any differences in outcomes are due to the treatment being studied and not some other factor.
Okay, so like if we were testing a new sleep medication, we would randomly assign some people to get the medication and others to get a placebo.
Exactly.
Okay.
Which is just a sugar pill that looks like the real thing.
Right. And ideally, neither the participants nor the researchers would know who is getting what.
Right. That's called blinding.
Blinding.
And it really helps minimize bias.
Okay, very cool.
Yeah.
The study guide also mentioned something called matched pairs experiments.
Right.
What are those all about?
So in a matched pairs experiment, you have participants that are paired up based on similar characteristics.
Okay.
And then one person from each pair is randomly assigned to each treatment group.
Okay.
So what that does is it minimizes the influence of other characteristics on the results.
So if we were testing that sleep medication again, we might pair people based on their age or their usual sleep patterns or maybe their stress levels.
Exactly.
And then from those pairs, one person would get the medication, one person would get the placebo
Exactly.
to compare.
Yeah, we're comparing apples to apples.
I see. I see. That's very cool. So it's all about very carefully controlling the variables to isolate the true effect of the treatment.
You got it.
I think I'm getting it.
Yeah.
And remember earlier we talked about randomness.
Yeah,
We've got the random sampling to get a representative group.
exactly.
And then we have random assignment to make sure the treatment groups are comparable.
Right. Two types of randomness, both very important for getting reliable results.
So there's so much more to data than meets the eye. And like by understanding these concepts, we can start to decode all those statistics that we see in news headlines or research reports or even advertisements.
That's right. Instead of just blindly accepting, that
Yeah.
studies show, we can actually dig a little deeper and figure out, where did this data come from? How was it collected? Are there any potential biases at play?
Are there any confounding variables?
Any confounding variables, exactly.
So then we can make up our own minds about whether the conclusions are actually supported or not.
Exactly.
That's pretty cool.
It's empowering.
Yeah. And the world of data, it's constantly evolving.
Oh, absolutely.
There's always new things to learn, new techniques, new insights to uncover.
So keep those thinking caps on.
Keep thinking critically about the data you encounter
Exactly.
and never stop learning.
Never stop learning.
Awesome. Well, thank you so much for joining me on this deep dive into data and statistics.
It was a pleasure.
And we'll see you next time.
See you next time.